So we're learning about direct, joint, and inverse variation, which is really just a relationship between two variables or two things that can change in your problem. So there are three types of variation. There's direct, there's joint, and there's inverse. Direct variation is y equals kx. Joint variation is y equals kxz. I'll show you what these formulas mean in a second. And inverse is y equals k over x. In all of these examples, k is a constant. So usually we think of the letter c being a constant, but for some reason they use k as a constant. And the variables are not always y, x, z, or y and x. In these cases, it's really whatever letters are in the problem. So for this first one here, it's direct variation. And it says A varies directly as B. So whatever variable you see first, you're going to write that down. And the word varies is a verb, so that indicates an equal sign. Direct variation, we're going to use this first formula. So we're going to have our K, and directly is B. So B takes the place of that X. So it's always whatever letter comes first and whatever letter comes second. And in this case, whatever letter comes first, second, third. So what you do is you take the information that they give you first. So they say B equals 0 when A equals 5. And you plug those numbers in to your formula. And the first step we're really doing is we're solving for our constant or our k. So 1 times k is just 1k. I like to write it that way better. And divide by 1. So our constant of variation is 5. And then for our second step, we're going to take whatever information is given to us in the second part, and we're going to find whatever letter they want us to find. So they're asking us to find B. So we use our same formula, but this time we know our K. But we don't know our B, and we know our A is 2. So 2 equals k times 5, which is 2 equals 5k. Once again, switching the order of these makes it a lot easier. Divide by 5, sorry, not 2. And we get that our, oh, I typed that in there backwards. My apologies. Need to redo that. See, even I mess these ones up sometimes. So we know A is 2, so we did that part right. We know our K is 5. We don't know our B. So when we solve for B, we do the opposite of multiplication, which is division. So B would be 2 over 5, which could also be written as 0.4. So first step is always to find the constant of variation. What is the relationship between B and A? And then the second step is to solve for whatever letter is unknown using the K that we've just found and plugging that in and whatever is given to us. So for number 2, M varies inversely as N. N equals 6 when M equals 2. So the first thing we need to note is that since M varies inversely as N, we see that m first. So it's m equals k. And then since it's inversely, instead of multiplication, it's going to be m equals k, like we see here for inverse over n. So that word inversely indicates inverse variation. The k is always on top, and whatever letters you have go in there in whatever order. So we're going to use our n equals 6 and our m equals 2 and plug those into here. So 2 equals k over 6. Because n is 6, you want to plug it in on the bottom. We're solving for k. Since we have division, we want to do the opposite, which is multiplication. 6 times 2 is 12. So our constant of variation is 12. First step is solve for k. Second step is to find whatever letter they're asking for. So it asks you to find m if n is 3. So we'll take our same equation. We now know that our k value is 12. So we can plug 12 in for k. And they're telling us that our n value is 3. So m equals 12 over 3, which is division. So m would be 4 if n was equal to 3. Once again, finding that constant to start, using whatever formula aligns with the inversely or directly. It'll say jointly if we're doing joint variation, and making sure you plug in the variables correctly. So we have an example of joint variation. We're going to use our joint variation formula here. In this case, it says z varies jointly as x and y. So we have to watch the order of the letters. So whatever comes first, that goes first. So z equals, because varies means equals. We always have that k, and since it's jointly, it's multiplication as x and y. So first step, kind of set that up. Take the first 3 numbers they give you, x equals 3 and y equals 8 when z equals 2. Plug in those numbers wherever their variable is at in parentheses. So we have 3 and 8 for x and y and 2 for z. And to solve for k, we'll go ahead and multiply those two. So we have 24k equals 2. Divide by 24. You can leave that a fraction, but usually k is better if it's a decimal. So we'll go ahead and do 2 divided by 24. And we'll get our 0.083, which I'm just going to make 0.08. So first step is to solve for k. Our second step is to find z. So they're asking for z when x is 2 and y is 1. We now know our k is 0.08. We don't know our z. But we know our x is 2 and our y is 1. So we'll plug those in. Since these are all side by side, we'll multiply, which turns out to be 0.16. So z equals 0.16 once we have our constant of variation and our 2 variables. Now, some of these problems are going to have more words, so they're more like word problems. So you'll get to choose what variables you want to use. So you always want to kind of look and see if they helped you out with that already. They might give you a suggestion. So the number of gallons of fuel used on a trip varies directly with the number of miles. And they even say G for gallons. So G equals K. Since it's direct variation, we'll use our direct formula here. So K times X, which in this case is M for miles traveled. If a trip of 270 miles required 12 gallons of fuel, so those are the first two numbers, how many gallons are required for a trip of 400? So you're going to use these first two key pieces of information to solve for K for our first part. So 270 miles, so that would be plugged in for M, K times 270, used 12 gallons of fuel. This is where a calculator will come in handy. So if we're solving for K, we'll go ahead and we'll divide 12 by 270. And we get a 0.044. Or if you want to round it to 0.04, that's fine. As long as you show me your work on how you round, I'm not too picky on that. Now they're asking how many gallons are required for a trip of 400 miles. So you're going to use your same equation, and we're trying to solve for gallons. So I'd put question mark. We know that K is 0.04, so we can plug that in. And this specific trip is 400 miles. So 400 times 0.04, a 400-mile trip would take 16 gallons. You can just write G equals 16 or 16 gallons. So it's the same exact steps, it's just identifying if it's direct, inverse, or joint variation, solving for K, using the first couple numbers in your problem, and then solving for the missing variable. To balance a seesaw, the distance a person is from the fulcrum is inversely proportional to the weight. So the keywords here is inverse, distance is the first letter you see, and weight. So it will be D equals, because that's the first letter, and it's K over, because it's inverse. And it's inversely proportional to the weight, so the W on the bottom. Roger, who weighs 120 pounds, is sitting 6 feet away from the fulcrum. So you have the first two numbers. So to solve for K, we're going to plug in 120 for weight, because that's a weight measurement. And the distance would be the 6 feet. So for step one, if we have division, we want to do multiplication to solve for K, which is 720 for K. Plug in your first two numbers to find out what your constant of variation is. Now, Ellen weighs 108 pounds, and they're asking how far should she sit? So we're trying to find distance. And we know her weight, so that can go on the bottom. And we also know our K, so that can go on the top. 720 divided by 108 is a distance of 6.6, or about 6.7 feet, because we can round up. Once again, as long as your work is right, I'm not too picky on the rounding. And you can see that makes about sense, because this person only weighs a little bit more than Ellen, and they're 6 feet away. So if word problems overwhelm you, just look for the key information and kind of go from there. That seems to help a lot of people. The value of real estate, V, varies jointly. So we know it's V equals K, and that jointly indicates multiplication. So it varies jointly with the neighborhood index, which is N, and the square footage of the house, which they call S, or square footage. So these are the two things that make a house worth a little bit more. So we want to use the first numbers they give us here. So they say if V equals 376,320, when N is 96, so just plugging it in where you see it, and the square footage is 1,600, find the value of the property, et cetera, et cetera, et cetera. Okay, so when it starts saying like comma or find this, you want to focus on solving for K first because we have enough information, and then we can go on to solving for V for the next one. So 96 times 1,600, probably use a calculator for that one. It's a really big number. Drop this down. And then solving for K, we want to divide. It was a 153,600. So we're going to take our value of our property, divide by that, and we'll get the constant is 2.45. So it asks us to find the value of a property, and it gives us two new numbers when N is 83 and S square footage is 2150. So this time we don't know V. We have our K is 2.45. I'm going to write a little dot for multiplication. We know our index is 83, or our N. I'm going to have to write that down to here. And a times sign, because they're all multiplied. And our S is 2150. So we're taking our K, plugging it in, our N and our S, and we're multiplying those three together to get the volume. So 2.45 times 83 times 2150. That tells us that the value of that home based on its index and its square footage would be about this much. I'm going to go ahead and round it up actually to 203 because I got a 202.50, and I've never seen a house be marked with 50 cents. So let's just go ahead and round that up to nearest full number. Once again, not too picky on the rounding as long as your work is correct. That one was a little tricky just because the numbers were so big, but try not to let these word problems overwhelm you too much. You can focus in on the key information and decide like what formula you're going to use first between direct, joint, and inverse. Plug in to solve for K using the very first information you're given, and then kind of backtrack. It does get easier with time. And let me know if you have any questions.